So let's mess around with Flink. I've already kicked off my virtual box here for the Hortonworks sandbox, as always. So first thing we'll do is log into it with SSH, Maria_dev. So Flink does not come pre-installed with Hortonworks yet, at least at this point with Hortonworks 2.5, so we need to go get it and install it. Fortunately, that's pretty easy to do. Let's just open up our web browser here, and I've gone to flink.apache.org. Let's click the Download Flink button. And it doesn't really matter which one of these you choose for this exercise because we're not actually going to be running on top of Hadoop or using Scala. So, just pick one. It doesn't really matter. Let's take this one, Hadoop 2.7 download. And this should give us a list of mirrors that we can actually download the file from. So I'm going to right-click on that in my browser and say Copy Link Address. And then over here, I can just type in wget and hit right mouse button there to paste it into PuTTY, and down it should come. So for this experiment, we're just going to be running Flink in standalone mode, not on top of our actual Hadoop or Yarn cluster, because we just want to mess around with it. What we're doing is just going through one of the examples on the Flink website that come pre-packaged with Flink. So again, we're avoiding the whole hassle of building and compiling code of our own, but I just want to show you that Flink works and give you some familiarity with what it does and what its UI looks like. Okay, so we've downloaded the package. We need to uncompress it now, so we can just say tar-xvf Flink, whatever it is we just downloaded. And that put it inside a Flink 1.2.0 directory. Of course, the number may be different for you depending on what you downloaded. And in here we have the usual suspects for subdirectories, bin, lib, conf, and all that good stuff. One thing we do need to change in the configuration is the port that the web UI for Flink runs on, because again, we have these limitations in our Hortonworks desktop where a port needs to be allowed both through Docker and through the virtual machine itself before we can actually hit it from outside the virtual machine. So let's cd into conf thusly. Take a look. The file we want is flinkconf.yaml. So let's say vi flinkconf.yaml. And we're going to look for port 8081, I believe it is, the default for the web UI. There it is, job manager web.port. So let's move over there with the cursor, hit I to go into insert mode, and from here I can edit that. And let's change it to 8082 instead, because I happen to know that port is open. Hit escape, :WQ to write and quit out of VI. And at this point, we can cd back up into our Flink 1.2.0 directory. And now we can actually start Flink. It's just that easy. So to do that, just do /bin/start-local.sh. That's it. No parameters. That's all you need to kick off Flink in local mode. Obviously, on a real cluster, you wouldn't do that. You would properly deploy it across your entire cluster. But again, we're just doing this for the sake of demonstration. So now that that's running, we can actually pull up the web UI, and we said that would live on port 8082, right? Sure enough, there we have it. So we can see that we're running one task manager, and we have one available task slot because we're just running this as a standalone server, but that's fine. We're only going to run one task. Right now, there are no running jobs, no completed jobs, because we haven't done anything yet. So let's take care of that, shall we? Let's do something interesting. So what we're going to run is another word count example. This is one that comes with Flink, and I'm just going to look at the code here in GitHub. That's currently a copy of it. This might change over time, but here's what some real Flink code looks like. And you're going to notice that it looks an awful lot like Spark streaming code, and not only because it's in Scala, like a lot of Spark code is, but because of the way that it's structured. So anyway, you import a bunch of stuff that brings in various Flink libraries that you might need. You create an object for we're going to call it socket window word count. And what this sample does is it listens to a socket on a given TCP socket on a given port for words that come in. So you can just type in sentences, and kind of like the other examples we've done, it will count up the number of times each word appears over time. So these windowed word count samples are kind of like the hello world of the streaming world, it seems. They keep coming up, don't they? So we have a main function, and we do some basic initialization, parameter parsing stuff, printing out help and all that stuff, not important. We get a stream execution environment that we work with, and we say get a socket text stream from that, so that with one line of code, we can start processing streams of data coming in from any TCP port. And then, again, with one line of code, we do pretty much everything. So this looks, again, a lot like Spark code, doesn't it? We take that text stream, and we can call flat map on it to blow out individual words from sentences. So that's just splitting out words from a sentence based on white space. That's what //s means, split based on white space. We then map that to these word and the number 1 tuples, and then we do a key by word. So that's reducing it back down, getting you the count of all those ones for each word 1 pair. And here we say time window with a 5-second window time. So that's going to do tumbling windows, where every 5 seconds we go back to what's been received in the past 5 seconds down to the event level and summarize all the word counts within that 5-second window and sum them all up by count. And we just say we're going to run in a single thread because that's all we have right here, and we execute it, and that's it. So that is your entire Flink application. You can see it's quite simple to do something like this in Flink, and very comparable to Spark Streaming, as I said. So let's play with it. Let's actually run it. First thing we need to do is actually open up a port to listen to. So we're going to use a utility called netcat. And what netcat does is it's just a Linux command line thing that lets you type stuff into the console and it will just echo it out to a TCP port. So let's type in nc-l9000, which means we want netcat to listen to stuff that I type in and broadcast it on TCP port 9000. And we'll just let that sit there. Let's open up another window. Maria_dev. From this window, we're going to actually kick off the streaming job itself for Flink. And to do that, let's first navigate into the Flink directory that we set up earlier. And we can say /bin/flink run, and then the jar file that we want to execute. So example, streaming, socket window word count.jar. So when you compile a Scala application, you end up with a jar file at the end of the process, and that's what we're actually working with here, the compiled version of that code that we just looked at. And for a parameter, we'll give it --port 9000. So that will tell the script what port to listen to for its streaming. Ka-ching. All right, let's let that kick off. And now, if we go to our UI, we should see that Flink is running this thing, and it's just sitting there waiting for input to process. So sure enough, running jobs, socket window word count, and we can click on that and get more details about it. So you can see it shows a little graph of what it's doing. In our case, it's very simple because we're running in one process, so it just does everything in one big glob. But yeah, that's the UI. You can actually get some visibility into what's running and how it's running it, so it's kind of cool. You can also take a look at running jobs, completed jobs, of which there aren't any yet, and individual task managers, so good stuff. So let's actually feed it some data and see what happens. Now to actually see the results, we're going to have to look at a log file, because again, we didn't really connect this to anything interesting for output. Let's bring up another window here so we can do that later. Whoa. Maria_dev. All right, so back over here, let's type in a sentence that contains a few words more than once. I don't know. I am a rock, I am an island. And if I do another word, again, within 5 seconds, that should show up too. Rock. Oh, I did talk. Rock. Let's see if that got in there. So let's see what we end up with in the output. So down here, let's go to cd flink 120. And in here, there should be a log folder. And the .out should contain our output. So flink dev job manager .out, thusly. Sure enough. Cool. So you can see here that it actually worked. The word I appeared twice. The word am appeared twice because I said I am a rock, I am an island. I mistyped the word rock as talk once, which appeared once, but I got the word rock in again within that 5-second window. So we actually got a count of 2 on rock. So you can see the Flink job is actually counting up words coming in from the stream in real time, and this will just keep on running as long as you let it. So cool stuff. Flink in action. It actually works, and it wasn't that hard to set up, was it? To get out of this, we can quit out of this window here, exit, and as soon as we hit Control-C on netcat, that will actually kill our streaming job from Flink as well because it lost its connection to the stream. So you can see over here that shut down as well. But just to clean things up properly, let's shut down the Flink service itself. So we can type in /bin/stop-local.sh to stop the local Flink service. And at this point, we're safe to shut everything down. And we're done. So that's Flink for you. Cool stuff. So there you have it. Not only have we covered how to stream data into your cluster in real time in a few ways, we've also covered a few ways of processing that data in real time. So now we've covered both how to deal with batch data that's in your system and processing things on a batch basis, and also processing things in real time as it comes in. which is a pretty powerful thing, right? So you can imagine building a system that generates new recommendations or something as new behavior data comes in instantly. So it's instantly responsive to new changes in a customer's behavior. That would be kind of cool. The possibilities are endless. That's just one of them. This has a lot of applications and things like Internet of Things applications and things of that nature too, but use this power for good. It's very powerful stuff. With that, let's move on.